In this video, I'm going to go through section 5.5, which is the multiplication rule for dependent events. So the general multiplication rule is as follows. So the probability of the intersection of A and B, remember, which means the probability of A and B both occurring, is equal to the product of the probability of A times the probability of B given A has already occurred. So that conditional probability of B occurring after A. So in the first example we have, in July in Virginia, the temperature can quickly rise above 90 degrees Fahrenheit, which can also lead to thunderstorms. The probability that a temperature will rise above 90 on a randomly chosen day is 0.68, and the probability of thunderstorms is 0.29. If the temperature rises above 90 degrees, the probability of a thunderstorm is 0.56. Okay, so we have three different probabilities. Let's look at what they're asking. What is the probability the temperature rises above 90 degrees? I'm going to call that event A, and there's the thunderstorm on a randomly chosen day in July. So they want us to find the probability of A and B, which means we need to know the probability of A times the probability of B given A. So if we look at our probabilities, event A is that the temperature rises above 90, so that's that first probability they gave us. So that probability is going to go there. And then we have two different thunderstorm probabilities. We want the one that is conditional, that implies that it was 90 first. Then it tells us the probability of the thunderstorm, which is the second one. So they're giving us three probabilities. We only are using two. So you know that in the multiple choice questions, they're going to give you an option of the 0.68 times the 0.29, but the correct calculation here is you're going to multiply 0.68 times 0.56. And so that product should give you 0.38. Okay, so one more we've got. A high school math class has 28 students, 18 seniors and 10 juniors. What is the probability that 4 randomly selected students will be seniors? So we've got the probability that we select a senior and a senior and a senior and a senior. And so since this is given to us in amount of the students instead of as a probability, we have to use the ratios. So if I think about the first senior is chosen, there's 28 total students. So that means that the probability that the first student chosen is a senior is 18 over 28, okay? I need to choose 4 seniors. So I'm gonna have to multiply 4 probabilities together to find that value. And then after this, they're all conditional. So now this is the probability that I choose a senior, knowing I already chose a different senior. So what's happening here then is that one of these seniors is gone. So that means there's only 17 seniors left. There's also only 27 students left. Okay, so then in the next round, okay, I've got 2 students gone. So there's 1 less senior and 1 less student. And then finally, I've got 3 seniors chosen. So I have only 15 seniors left to choose from and only 25 students left to choose from. So then to do this problem, I want to multiply across my numerators and across my denominators to find that value. I could also excuse me, divide each of the fractions and get the decimals and multiply. So either way, I should end up with the same answer. So if I multiply across, I get 73,440. And then if I multiply across the denominator, I get 491,400. And then when I divide that, I get 0.149. So I'm going to round that up to 0.15. Okay, so the probability that 4 randomly selected students are seniors is 0.15 or 15%. The rest of the videos talked about tree diagrams. So tree diagrams show the sample space of a random process involving multiple stages. All of the probabilities after the first stage are conditional probabilities. If there are 2 branches from one stage of the tree diagram, then the event in each branch is the complement to each other. Remember, that means that they add to 1. So if you only know one of them, you just have to subtract from one to get the other. The product of the probabilities across a branch is the probability of the intersection of those events. It's the and probability. So if I multiply across, it'll give me an and. So what we're going to do in this example is practice filling in the tree diagram, because there are problems where it will ask you like what goes in number 1, number 2, number 3, number 4, number 5. We're just going to fill in the entire thing, and then we're going to use it to answer questions. So a medical clinic is randomly selecting 2 staff members to attend a conference. The clinic employees include 7 nurses, 3 doctors, and 2 office staff. The nurses want to know the probability that both attendees will be nurses. The tree diagram displays the possible outcomes of randomly selecting 2 staff members. Fill in the tree diagram to answer the questions. So there's 3 different groups of people, right? Doctors, nurses, and office staff. So because there's only 2 branches, they're only concerned about it being a nurse, right? So the complement of being a nurse is not being a nurse. So that means that all they're concerned with is the person a nurse or not a nurse? So it doesn't matter if they're a doctor or office staff. On the arrows, that's going to be the probabilities. So if I think about this, there's 7 nurses, 3 doctors, 2 office staff. There's 12 employees. 7 of them are nurses, so that means the probability here is going to be 7/12. There's 3 plus 2, so 5 out of 12 are not a nurse. Okay. So then I'm selecting 2 staff members means that these are going to repeat. So I'm going to put just N for nurse and then not N in these boxes. So then the second person is also going to either be a nurse or not a nurse. So then the next branch of probabilities, so of the 7 and 12 people that we have that are nurses, 1 is chosen. So that means that there are 6 nurses left out of only 11 people. So for the second branch, because 1 person has been chosen, there's 11 people left. So since it was a nurse that was chosen, there's still 5 not nurses left over. For the second branch, we've chosen someone that wasn't a nurse. So that group is going to go down. So there's 4 people that are not nurses that are left over, and only 11 people left to choose from. And then the probability that a nurse is chosen, remember that 1 person was already chosen. They were not a nurse though, so there's still 7 nurses left in the pool. So then we're going to use this to find some and probabilities. So what is the probability that both attendees will be nurses. So they want us to find the probability that we choose a nurse and then a nurse. Okay, so the way that this works is we're going to follow the branches and multiply the probabilities. So to choose a nurse and then a nurse, we're going to multiply 7 over 12 times 6 over 11. So when we do that, we get 7 over 22. Because the 6 reduces with the 12 to become a 2, which is about 0.32. Okay, and then the second one is asking, what is the probability neither attendee will be a nurse? Remember that not being a nurse is the complement of being a nurse. So I'm going to write it that way so that I don't have as much to write. So they want us to find the probability that it's not a nurse, and then the second person is also not a nurse. So that branch follows this way. So I'm going to do the probability that they're not a nurse times the probability that they're not a nurse given that they were first chosen not to be a nurse. So that means I'm going to multiply 5 over 12 times 4 over 11, which I can reduce this one too. So that 4 can turn into a 1, and then that goes in 3 times. So that's going to give us 5 over 33. Which is about 15%. Okay, so that's how we fill in a tree diagram with information and then use it to calculate probabilities. Remember that there's 2 other probabilities we could calculate. This product at the end of this one would be the probability that you choose a nurse and then not a nurse. And then this probability that we didn't find would be the probability that you choose someone who's not a nurse and then you choose someone who is a nurse. In this last example, we're going to look at a more complicated probability using a tree diagram. So they filled in the tree diagram with the information given in the problem. So you can see that 45% of customers get the basic wash, 35 get the classic, 20 get the ultimate. Those values are noted here on those branches. And then after that, they're looking at who vacuums versus who doesn't vacuum. So after each wash, they give you the percentage of people that vacuumed, which are these top values. So 10% vacuum if they got the basic wash. So they subtracted that from 1 to get 90% for no vacuuming, and so on for the rest of the different types of car washes. And so we are asked in this problem to find the probability that a randomly selected customer purchases a classic car wash. So I'm going to use C for classic, given they do not vacuum their car. So I'm going to use the complement of vacuum, V, there. So what is the probability that someone purchases the classic car wash given they don't vacuum? So in the previous problem, we multiplied to find and probabilities, right? So if I were to multiply classic to no vacuum, that would give me the probability that someone purchased the classic and didn't vacuum. And so that would be 0.35 times 0.75, which is 0.26. Okay, so that gives me that and probability. This probability here is the probability that someone chooses not to vacuum given they got the classic car wash. So the value that I'm looking for is not in my tree diagram. I have to do some work to get there, okay? So if we think about the formula for conditional probability, that tells us that the probability of A given B is equal to the probability of the intersection of A and B divided by the probability of B. So what's good is that right now we have that intersection value here. Okay? So what that means is that our numerator for this answer is going to be 0.26. We are going to have to do a little bit more in order to find the value for the probability of B. So the probability of B is going to end up being the sum of all of the different places where they cannot vacuum. So for each car wash, if we find the and probability of not vacuuming and add those all together, that's the probability of B. So that means that the probability that they chose a basic car wash and chose not to vacuum, and the probability that they chose the ultimate car wash and chose not to vacuum, plus the probability that we already found, is going to give us the probability that they chose not to vacuum. Okay, so let's look at what each of those probabilities are. So if I multiply 0.45 times 0.9, that gives me 0.41. And then finally, if I look at 0.2 times 0.4, that's going to give me 0.08. If I add these up, that's going to give me the probability that someone chose not to vacuum, because it's all the situations where they were not vacuuming. So the sum of that is 75%. So that value is going to go in the denominator. And so if I divide those two, that gives me 0.35. So that means that there is a 35% chance that a randomly selected customer purchases the classic car wash if they do not vacuum their car.